Okay, so let's have a quick look here. Is it better? That's for sure better. You like that or you like that? Is that better?
Yeah.
Okay. I mean, it sure does look better up here, I guess. Okay, so quick review. Oh, I got stuff for you too. Here's everybody here. Everybody come up and grab one of those. And then let me print out the other ones. I forgot about these. You can add these to your notes. Okay, so here we go. We got properties of exponents. So we've already reviewed all this stuff, but it plays a big role in the next stuff we talk about, which is polynomials. Polynomials are a big deal. Polynomials are they're the most typical way that we can model functions. So if you got some data and you want to make some predictions based on the data, polynomials are a good way to, you can fit the data using Desmos or a graphing calculator, and you can make some pretty good predictions about what's going to happen in the future with this data, right? For example. Okay, so what do we do if we multiply x cubed times x squared? What's the result?
Use x6.
No.
x5.
But we wouldn't say x5, we'd say x to the fifth power, right? Okay. How come? What's the rule?
You
Add exponents.
Okay, yeah, if I multiply like bases, I add exponents, right? And let's take a second and let's just review what the anatomy of a power looks like. So that's a power if I have something like a to the n, right? So what do we call this part of a power? The exponent. What do we call this part?
Base.
The base. Okay, good. Right. So there's a power, exponent, and a base. If we have like bases, we add the exponents. What do we get from this one? X cubed times y squared.
X fifth, x to the fifth, y to the fifth.
X to the third, y squared. That's it. Moral of the story, we can't do anything because we don't have like bases, right? We can't combine those. What about down here? What if I have x cubed times x squared times x to the fourth?
X to the 9th. Jinx. Everybody.
Yeah, good, because we just add them all up, don't we? Really, this should make sense. If I've got x cubed, what is that really? I mean, that's like saying x cubed is the same as x times x times x, right? What's x squared? So how many x's am I multiplying together? 5, right? Right? How about something like that? What's y to the fifth divided by y squared?
Y3. Y to the third.
Y to the third.
Because
Because
we divide, subtract.
okay, good. Because right, if we divide like bases, we subtract the exponent. So I get y cubed. Now what about this one right here?
Positive 4. X to the fourth.
X to the negative 4, 3 minus 7, right? But this also brings us to our negative exponent property. Oh, well, no big deal. Okay, so this also brings us to the negative exponent property. What if I want to write that in terms of a positive exponent? X to the negative fourth is correct, but a lot of times, like in Moodle on the assignments, I'm going to ask you to write it in terms of a positive exponent.
Negative x to the fourth?
No.
X to the fourth over 1.
What about say it again?
X to the fourth over, like, 1, I guess?
Close. 1 over x to the fourth.
Oh.
Right? What's the moral of the story?
Because there's no negative, you can't have negative.
Well, here's how we think about this. If we divide we can always write something as a fraction. This is really just over 1, isn't it? Right? I mean, anything can be written as a fraction. So if the exponent is negative on one part of the fraction, in this case the top, it becomes positive in the other part of the fraction, in this case the bottom, right?
Yeah.
So what about this example down here?
So it'd just be
Oh, then
X
it'd
to the
be
third.
X or
Yeah.
X third.
Because if it's negative in the bottom of the fraction, it's positive in the top, right? That's all a negative exponent does, is it sends it to the other part of the fraction as a positive exponent, okay? All right, how about that?
X to the 6.
Yeah, so what's our rule there? If I take a power to a power, what do?
Bigger power.
X.
But what, how do you get the bigger power?
You multiply those.
You take a power to a power, you multiply, and that makes sense because think what x cubed squared really is. It's just x cubed times x cubed, right? And that's, now I'm
Times
multiplying
the-
like basis, so I would add the exponents.
When did we learn this?
Where did you learn this? In Algebra 1.
Oh, that's right.
Yeah, but we reviewed it earlier in the year. Okay? It's just a matter of familiarizing yourselves with these, with these properties.
This stuff.
So this one looks pretty tough, but what's the
Zero.
answer?
Oh.
One.
It's 1, yeah.
Not-
It's just 1. How come?
There's a 0.
Yeah, because anything to the 0 equals 1, right? Always. Okay. How about those? So what about this top one?
That's 4x to the, wait, what?
So what is it again?
6.
Was that I have a cube there before?
Yeah.
Yeah, I did. Okay, so what do? If I have a product of a bunch of things are being multiplied, and that whole product is being taken to a power.
Here, I already have the answer.
Okay, what is it?
6, 8.
Ah, 8. How come 8? That's right. Ah, okay, good. Right, we have to distribute the power to each of the factors that's being multiplied. So this is the same thing as saying 2 cubed times x squared cubed times y cubed cubed. So what is 2 cubed?
8.
8. X squared cubed is x to the 6th. And we can see we're just going to multiply those, right? And then y cubed cubed
9
is,
cubed.
yeah, there it is.
Because that's y cubed, cubed, cubed.
Now what about the one at the bottom? What can I do there?
Oh, it's not 9 cubed. 9 to the 9. Y to the 9th power.
Y to the 9th, yeah. What about the bottom one?
4x cubed plus. Yeah, that's what. Yeah. 4x 2
4x squared plus
plus y to the 4th power.
y to the 4th. I see why you did it, but it's not right. How come?
Because the 2.
What's the difference between the two? There's a real important difference. Yeah, the plus sign, right?
Oh,
That makes this actually harder, right?
I thought that was a t.
When we have a sum, or it could be minus also. If I have a sum or a difference to a power, that's harder, right? Think what that's saying. That's not saying I can't distribute in this case. That's like saying that quantity times itself. If this were 2x plus y squared to the 4th, that'd really be bad. I'd have 2x plus y squared times 2x plus y squared times 2x plus y squared times 2x plus y squared. That's a big problem.
Big numbers.
I'd have to multiply the first two out, simplify, then get that result, multiply it by the third one, simplify, multiply it out, simplify, get that answer, and then multiply that by the 4th, distribute all the way through and simplify. That's a huge problem, right? It's much, much easier to do a product to a power. If I've got a sum or a difference, adding or subtracting, it's much harder. Now, we could do this one, though, because we know the pattern. What is our pattern for a plus b squared?
A squared plus 2ab plus b squared.
Good. Okay, so for us,
Good one.
this is like a, and that's like b, right? So instead of a squared, we're going to get 2x squared, right? Plus 2 times
y.
2x times
What?
y squared, right?
Oh.
Because look what I've got.
Yeah,
I've got
yeah, yeah.
a squared. I've got 2 times a times b plus, yeah, y squared, squared.
That's still
Right.
pretty big.
Sure, but we can do that. So what's the first term gonna give me then?
Oh,
4x squared, right? Because I've got a product to a power, so I'll just distribute the power to both, right? It's 2 squared times x squared. What about here? 2 times 2x is what?
4x
4x times y squared.
plus
Good, 4xy squared. And then finally, y squared squared is what?
5 to the 4th power. That's
Okay.
not bad, but not
No, it's not so bad, right? It's not so bad. It looks worse than it really is, right? So how about,
Writing that in Moodle's not gonna be that fun, but
oh, no, it'll be fine. Be fine. So what about this one?
I can do it.
Remember, multiplication and division are on equal footing. Just think about PEMDAS, right?
Add them
M and D go together, A and S go together, right? So what would we do? What did we do before? If we had stuff being multiplied to a power, we just distributed.
Just added them.
So, well, not really.
But don't you add your exponents?
No. If we take a power to a power, we multiplied, right? So we just distributed the power to everything. Same thing for division. Multiplication and division are on equal footing, right?
So x to the 12th power over y to the,
Exactly, yeah, so we're gonna distribute the 3 there and to the bottom, right? So I end up with x to the 12th over y to the 9th. Okay, no biggie, right? And then finally, what about something like that? What if we're gonna do, so I pulled a pretty hard one out of Moodle here. What are we gonna do with something like that, where there's lots of properties happening at the same time?
yeah, equation.
Okay, good, so there's a lot of stuff we could do, right? And if we follow order of operations, whenever we're simplifying, we should follow order of operations, right? So we're gonna do just regular,
MDOS.
PEMDAS, right? So we're gonna work inside the parentheses first. Well, what can we do in the parentheses? Quite a bit. What's v to the 0?
0 or 1.
1, right? So that just becomes a 1. So we can just cross that out, right? What else? Well, 3 over 8 doesn't simplify. There's no other like bases. But I can do some stuff. Well,
You have to move
Flip them.
I
so
could
they're
flip
all
stuff.
positive.
Yeah, I could flip some stuff. I certainly could. That would work. But
But
when
keep
I
that
get
up.
down to exponents, what am I going to do with this negative 3?
Distribute it.
I'm going to distribute it, aren't I? So let's think about this. Let's go ahead and flip stuff around. Okay, let's flip stuff around. So x to the minus 3. Let's just go through it like we normally would, because we're still inside parentheses. So inside the parentheses, the 3 is going to stay on top, the 8 stays on the bottom, the y squared stays on the bottom, right? Because that's a positive exponent. What happens to the x to the minus 3? On the bottom, right? What happens to the v to the minus 9th on the bottom?
Up top, make it positive.
There you go, good. Okay, so now we're done inside the parentheses. That's taken to the negative 3. So when we go to the exponents, now let's take one piece at a time here. What happens if I take a fraction to a negative power? Think what that's going to do. What did a negative power do? It made everything on the top positive on the bottom, and on the bottom positive on the top, right? I just flipped the fraction, don't I? Right? So this is equal to the reciprocal, so 8x cubed y squared over 3v to the 9th, to what power?
the 3rd.
The 3rd, yeah. Right. And so now, what do I do? Last thing to do.
Distribute.
I just distribute, sure. So we'll distribute the 3 to each of the factors. So there's 3 things on top, and there's 2 things on the bottom, right? So we end up with 8 cubed times x to what power? the top?
Uh,
9 times y to the
6.
divided by 3 cubed times v to the,
28.
27.
it is 8, you're right, to the 27, okay? So if we just simplify those parts, and really what the variables are easier, aren't they, to deal with than the numbers? Right, so we end up with, on the bottom, we're gonna have a 27 v to the 27 on the top, 8 cubed is 512, so we get x to the 9th, y to the 6th. So there's our answer. Okay, does that make sense?
Uh-huh.
Okay. All right, so for today, I'm just gonna turn you loose on that. Okay, so there's 2 assignments there for Unit 6 on simplifying, using properties of exponents to simplify expressions. I think that's, yeah, so work on that stuff.